G is 12 degrees, angle G that is. Side G is 2, and I, look at that, is 7. So we're sort of stuck as far as what order we have to go in. What do we have to find first? Angle I. So let me write this off to the side. Yep, we have to find angle I first. So what's the setup to find angle I? Over G equals good. So we're going to have the sine of 12 degrees over 2 is equal to the sine of I over 7. So to solve for angle I, we'll multiply both sides by 7. And then when we take a sine inverse to solve for I itself, what do we get? And if you would, let's go, I don't know, let's go 1 decimal place. Again, on the test, I'll tell you how far to round. Unless I forget to tell you how far to round, then I won't tell you how far to round. What do we get? Yep. Oh. That's in degrees. Now, we just took a sine inverse to find an angle, so now we have to consider the supplement. What's the supplement of 46.7? Yeah, so subtract it from 180. 133.3. Yep. Is 1 out of 90. Is 133 also a possible answer for angle I? The correct answer is yes. Because if I was also 133.3 and our given angle is already 12, 12 plus 133.3 is still less than 180. So we could have 133.3 as an angle for I. So if in your calculator you don't believe me, if you did the sine of 46.7 and you did the sine of 133.3, you get the same answer. Because remember, in quadrant 1 and quadrant 2, you have the same sine value, because those are the values that are above the x-axis. Again, 46.7 is the reference angle for 133.3. So when you take a sine inverse, you have to consider its supplement. If the supplement is also a possible triangle, then you have 2 triangles. We have 2 triangles. Copy. See how well this works today. Oh, paste. Oh, nice. Good job. That's good. So in the left-hand side, we're going to have I is 46.7 degrees. And the right-hand one, we're going orange. We're going to have 133.3 degrees. So we're going to have 2 triangles. And that means that H and little h are going to have different values depending on what triangle you are in. If you would, figure out what H and little h is or were for each triangle. Which would you start with, the angle or the side? Yep, you have to go with the angle next. All right, let's find H. Oh, I'm in orange. We can't have orange over here. That's terrible. Bam. All right, let's find H. There it is. So we'll do 180 minus the quantity of 12 plus 46.7 degrees. What do you get for this 180? I'm sorry, what do you get for this H? Did anyone else get that? 21.3? 0.3? All right. I'll put it over here. All right, now that we have angle H, we can use our given pair G and G to find side H. So you have H over the sine of H. I'm just going to go right to it. 121.3 degrees equals side G, 2 over the sine of angle G, sine of 12 degrees. The given number, right? Otherwise, what's going to happen is that if you use an approximation, it's going to be an approximation of an approximation. True, but if we have this being approximated and then these two being approximated, well, 7's not approximated, but 46.7 is an approximation. It's a little bit better. And technically it's still approximately. It's a fancy word, I know. So we multiply both by the sine of 121.3 degrees. Hey, I can't see it anymore. There it is. Also going to one decimal place, what do we get for H? 8.21? Did anyone else get that? Awesome. Well, we're halfway done. Now we got to do the other triangle. So let's find this angle H. What do you get for this angle H? Huh? 34.7? Good. And then what's the setup for side H? Yep. So H is going to turn out to be, what would that be, 2 sine of 34.7 degrees over the sine of 12 degrees. Before H was the largest angle, so it should be the largest side. Here H is the middle child, so it should be the middle side. So it has to be an answer between 2 and 7. 6 point something. 5.5?